Hello, everybody, and welcome back to the math series presented by Your Perfect Squares. Today's lesson, we'll be going over fractions, decimals, and percents. And the math square says that there is a fine line between numerators and denominators. Get it? Well, don't worry about it. We'll get this lesson together. So let's get started.
We have one whole circle. If we were to take that circle and cut it into two pieces, and then remove one, we just have one half of that circle over here. Now, the fraction has two parts of it. It has the number on the top of the fraction and the fraction bar, the number in the bottom of the fraction. The top number is called the numerator, and the bottom number is called the denominator. The top number represents how many parts of the circle you have. Right, we have one part of that circle. And the bottom number, the denominator, tells you how many pieces you need to make the whole circle. So this would represent the whole object if you had all of those pieces. So we have cut it into two pieces, and we have one of those. So this is one part of the two, right, or half of the circle. Now, if we want to, we could represent the entire circle, right? If we had both halves of this, we could take those. And now we have both halves of the circle. And so we would say we have two parts, and the circle is cut into two parts. Now, if you simplify that, 2 divided by 2 equals 1, and we have one whole object. If we were talking about circles, it'd be one whole circle. Okay, now we're going to go ahead and chop this up and show you how that works with the fractions. I want you to pay attention as we cut the circle into more pieces. What happens to the size of the piece and the denominator, okay? So the first one we did, we have cut it into two pieces, so this would be 1/2. Now if we cut it into three pieces, we took that same circle, broke it into three equal pieces, keep one of those, so this would be 1/3 of that circle, right? Now, if we were to take that circle and again cut it into more pieces, this time we'll cut it into 4 pieces. So there we go. Here's our circle. We're going to break it into 4 pieces. And if we just had one of those, we would have one part of the 4 pieces necessary to make that circle. Okay. And now let's say we broke it into 6 pieces. We would have, this would represent 1 out of 6 pieces. And if we did it some more, broke into more pieces, let's say we cut it to 8 pieces, this would represent 1/8 of the circle. Notice the sizes have changed, right? We went 1/2, 1/3, 1/4, 1/6, 1/8. The denominators, 2, 3, 4, 6, 8, keep getting bigger. But if you look at the size of the pieces that it is cut into, they're actually getting smaller, right? So as the denominator increases in value, the numerator, the pieces up here, the parts that we have, are actually getting smaller, right? So we have smaller parts that we're talking about. Okay. Now, we can compare fractions, right? And when we compare fractions, we use 3 symbols to compare them. And the symbols that we use are going to be greater than, less than, or equal to. So here's your greater than symbol. Less than symbol. And of course, the equal sign is the equal to. Now, you might have learned in kids that you have an alligator and it goes after the larger number. So whichever side this is on, it's open over here. It's trying to eat that bigger number. In middle school, you guys need to know if it is open on the left-hand side like this, this is greater than. If it is open on the right-hand side, this is less than. Okay, use those properly, please. So when we compare fractions, we need to be able to do that in a way that is meaningful. So we need to have either like fractions, which like fractions have the same denominator. And they're pretty easy to compare because you can say, okay, well, I've got 3/4, and I want to compare that to 1/4. Well, the pieces are the same size. That's what makes this easy to compare to. We've cut them all each of one of these circles into 4 pieces, right? So they're the same size pieces, and we have 3 of them here and 1 of them over here. So obviously, if the pieces are the same size, right? We've got the same number of slices here. All we have to do is compare the top numbers or the numerators. And we would say that 3/4 is greater than 1/4 because 3 is 1 and the pieces are the same size. Okay, let's do that again. So if we were to have the fraction 6/7 and 7/7, so again, the denominators are the same, which means the pieces we're comparing are the same size. We have 6 parts over here and 7 parts over here. So 6 compared to 7, well, the 7 is larger than the 6. So we would say 6/7 is less than 7/7. Okay. And then, of course, let's go ahead and finish that with the last symbol we could use. We have something that's been cut into 5 pieces, and we have 3 over here and 3 over there. Well, there's the same number, the same size, so 3/5 is equal to 3/5. Now, you're not always going to have fractions with the same denominators. You're not always going to have like fractions when they ask you to compare these. Sometimes you have unlike fractions, and unlike fractions have different denominators, which means that the parts are cut into different size pieces. And it's going to be more challenging to compare those because, well, if you're comparing 3 pieces this size to 1 piece that size, you're not really sure if those 3 pieces are actually going to be larger than that piece unless you can overlay them, right, and see that. So at first glance, you might not be able to see, okay, I've got 3 of 6 pieces and 1 of 3 pieces. How would you compare those? So those are going to be unlike fractions. They're not going to have the same denominator. So have different. So let's go with 1/2. There's a fraction. First one we're going to compare. And the second fraction, let's make 7/8. So notice the denominators are different. So your options to compare these would to make them have the same denominator, right? Cut them into the same size pieces. Or you could convert them both to decimals. Now, Mr. Cameron's going to talk about that later. So for now, I'm going to talk about converting these to like fractions. And the way you do that, you're going to get the same denominator. And so what you do is you find the least common multiple of these two numbers. So 2 and 8. Well, let's get the multiple. So you've got 2. Next one, 4, 6, 8, 10, 12. And 8 would be then 16, 24, and so on. I don't need to go very far. I can see the first number that's the same is 8. So I just need to make this 1/2 match the 8 for the denominator. I won't have to do anything to this one because it's already got that common multiple that we want there. So we're going to convert the denominators. We're going to get the least common denominator here. And so what we're going to do is we're going to multiply this fraction, 1/2, by 4/4. We're going to multiply the numerator by 4 and the denominator by 4 to get our new equivalent fraction. And now we can compare those. So they're the same size pieces now. We have 4 here. We have 7 here. And so 4/8 is less than 7/8, which tells us that our equivalent 1/2 will also be less than 7/8. And you can actually, a quick tip for that one, if you're taking a standardized test and it's multiple choice and they just say, hey, which symbol are we going to use here? I like to just look at the denominator and say, okay, what would be half of this? Well, 1. So this is 1/2. Okay, what would be half of 8? Well, half of 8 would be 4. So if I have 4 of these, I'm at 1/2. Well, I have a lot more than 4, so this is going to be a lot more than 1/2. So this is going to be greater than 1/2. The next thing I wanted to talk about are mixed numbers and improper fractions. So mixed numbers, like it implies, is you're combining two things. You're combining whole numbers and fractions. So if we were to visualize this, we have one whole circle, and then if we were to add half of a circle, a fraction of a circle here, we would have one whole circle and 1/2 of a circle. And when you combine those together, you would have 1.5. So that's going to be a mixed number. It has a mixture of a whole number and a fraction part there. So they're pretty easy. The improper fractions are all represented in fractions. There's not going to be any whole numbers there. And so if we were to represent this as a improper fraction, you could say, okay, well, if I were to cut this whole circle into parts that are the same size as this 1/2, I would need to cut that into, right, 2 parts. So I would take that circle, cut it into 2 parts, and then I would have the part I started with, right, the 1/2 there. I would have 2 new 1/2s for a total of 1, 2, 3 parts. So I would have 3 parts, and I would need 2 parts to make one whole. So this 1.5 could also be represented as 3/2. And if you notice this, this fraction 3/2, they call this an improper fraction because the numerator is larger than the denominator. And normally that's not true. Another name for these are fractions that are greater than 1, right? Fractions greater than 1. And you can tell that because the numerator is larger than the denominator, which means you have enough pieces, enough parts to make a whole circle or whole object. So you only need 2, you have 3, so you have enough to make a whole one and some extra. So this would be a fraction greater than 1, also known as an improper fraction. Okay. Now you can convert back and forth in between mixed numbers and improper fractions, and it's pretty simple to do. So if you were to, let's go back to this 3/2. If you want to go back to 1.5, all you have to do to convert a improper fraction to a mixed number is divide the numerator by the denominator. So you'd say 3 divided by 2. And how many times does 2 go into 3? It goes into it 1 time. And then so 1 times 2 is 2. Subtract those. And we have 1. 2 does not go into 1. So we have a piece that's a part that's not a whole, right? We don't have an entire 2 here for this to go into. So we have 1 left over. And it's of the 2. So it's 1.5. And that's what we said at the very beginning, that 1.5 is equal to 3/2. Okay? So again, to convert from a improper fraction to a mixed number, all you have to do is divide the numerator by the denominator. And if it doesn't go into it evenly, the remainder gets written as a fraction, with the denominator being the same one you started with. So again, let's convert another one. So if we had 5/2, you would divide 5 by 2. 2 goes into 5 twice. So 2 times 2 is 4. 5 minus 4 is 1. 2 does not go into 1, so we have a remainder. So it goes into it 2 times, or we get 2 wholes. And then we have our leftover, our remainder, of 1. So that's 2.5. So 5/2 is equivalent to 2.5. Now we can go the other way. If we had, let's see, 5 and 3/4, we could totally go from this mixed number back to an improper fraction, which is actually pretty convenient in your algebra classes. In your more advanced classes, you like to leave them as fractions instead of mixed numbers. So let's go ahead and do this. And the way you do it, you kind of go in reverse. So we're going to multiply the denominator. I call it times e plus e. So multiply the denominator by the whole number. And so 4 times 5 is 20. And then we take this product that we got and we add it. There's the plus e. Add it to the numerator. And so we get 23. And then you simply write it over the original denominator. So 23/4 is the same thing as 5 3/4. So let's do that again. Let's do it with 3 1/8. Okay, so here we go. Times e. 3 times 8 is 24. Plus e. 24 plus 1 is 25. So 25/8 is equivalent to 3 1/8. So again, you're just going to multiply the denominator times the whole number and then add it to the numerator. Okay? That is how you go from a mixed number to an improper fraction.
Look at adding and subtracting fractions first. So here we have a couple of examples. 3/8 plus 4/8. Now, right off the bat, when you're adding, subtracting fractions, really you're only adding and subtracting your numerator, as long as you have a common denominator, as we do right here. So since our common denominator is 8, we know that this problem, your denominator is going to be 8, and all we have to do is add our numerator. So 3 plus 4 is 7/8, and that's our answer right there. Now we look at our other problem here. This case, we don't have a common denominator. So we need to think of what numbers 3 and 6 have in common. Well, for example, 3 can become 3, 6, 9, and so forth. And 6 can become 6, 12, and 18. And as you can see, the number that they have in common, or their least common multiple, is 6. So we'll have to change this number to 6, and to do that, we times this denominator by 2. And whatever you do to the bottom, you must do to the top. So we have to times the numerator by 2. So this becomes 4/6. And since our denominator for our other fraction is already has 6 as its denominator, we keep it the same, 4/6. And we add them. Now we have a common denominator of 6, and we just add our numerators. So 4 plus 4 is 8. And here we have an improper fraction. And usually we want to simplify and change our improper fraction to a mixed number. So let's change our improper fraction to a mixed number. And we know 6 can go into 8 one time, and then you're going to be left with 2/6. And then this 2/6, we can simplify that because they both have a number in common. As in, they both can be divided by 2. So we change that 1 and 2/6 to 1 and 2 divided by 2. Will give me 1. 6 divided by 2. Give me 3. So our answer to this will be 1 1/3 in its most simplified format. Now we have a mixed number. So when you have a mixed number and they have a common denominator, we can pretty much do the same thing, all right? We can add our whole numbers separately. So let's look over here, 2 plus 1, and then add our fractions separately. 1/5 plus 3 over 5. All right, so we all know that 2 plus 1 equals 3. And we have this 1/5 plus 3/5. Common denominator, we know it's over 5. 1 plus 3 is 4. And that will be my answer, 3 4/5. All right. Now, let's look at subtraction. We have 9 9/5 minus 4/5. So we have a common denominator, so all we have to do is subtract our numerators. Our common denominator is 5. Not 9 minus 4 is 5. Perfect. And since 5 can go into 5 evenly, our answer would just be 1. Now let's look at the next problem. 2 over 4 minus 5/3. Here we have to find a common denominator, so we know that 4 multiples of 4 is 4, 8, and 12, and multiples of 3 are 3, 6, 9, 12. So the least common multiple that they both have in common is 12. So for 4 to change to 12, we have to times 4 by 3. And we'll do the same thing with the 2. What you do to the bottom, you must do to the top. So this fraction changes to 6 over 12. And then 5/3 times this by 4 times this by 4. So this becomes 20 over 12. So now we have a common denominator. So no matter what, my answer is going to be over 12. Then 6 minus 12 is a negative 14. All right, we have an improper fraction, so let's change that improper fraction to a mixed number, and we'll get -1, because 12 goes into 14 one time, and we have 2 as this remainder over 12. And then we'll change this. We can simplify this number so it can equal -1, 1 over 6, because the number they both have in common is 2. We divided the numerator and denominator by 2. All right, so my answer will be -1, 1 over 6. Now let's look at our last problem here. So in this case, we don't have a common denominator. We don't have to worry about anything. All we have to do is change our denominators so that they're in common. So common multiples of 3 are 3, 6, and 9. And we know common multiples of 2 is 2, 4, 6. So we know the least common multiple that they both have is 6. So to change 3 to 6, we have to times it by 2. Whatever do to the bottom, do to the top. So now we have 5, 4 over 6 subtracted by times this by 3, subtracted by 3, 3 over 6. Now, do the same thing we did at the top. We can look at these separately. Just do 5 minus 3, deal with our whole numbers, and we know we get 2. And then we can subtract our fractions. So 4 over 6 minus 3 over 6. We have a common denominator, so that will be my answer. 4 minus 3 is 1. All right? Let me bring that up. So we have our answer of 2 and 1/6. All right, so this is a quick tour of how to add and subtract fractions. And if you continue down the sheets, there will be some practice problems that you can work on yourselves.
Most of you. So 1/2 times 2/3. So how do you do that? Well, it's pretty simple. You're going to multiply the numerators together. You're going to multiply the denominators together, and then you're going to simplify. Okay, so here we go. We've got 1/2 times 2/3. So you have the numerators being multiplied together, 1 times 2. You have the denominators being multiplied together, 2 times 3. So 1 times 2 is 2, and 2 times 3 is 6. And then the last thing you're going to do is you're going to simplify. And all that's saying is, does your numerator have a common factor with the denominator? And factors, remember, are things that you multiply together to make a product. So what would you multiply together to make 2? Well, you'd multiply 1 times 2. What could you multiply together to make 6? 2 times 3. So this has a 2, and this has a 2 as factors, right? So you would divide both of those by the factor of 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. It's 1/3. Would be the simplified form of 2/6. Let's do another example of that. So our fraction will be 4/7, and we're going to multiply that by 3/5. And again, remember, multiply across the numerator. So you get 4 times 3. Multiply across the denominator. That's going to be 7 times 5. So 4 times 3 is 12. And 7 times 5 is 35. Now, I don't know of a number or factor of 12 and 35 that's the same. So this is already simplified, and we would just leave it like that. So let's take a second. Let's talk about dividing fractions. Dividing fractions is very similar to multiplying fractions. We just have one extra step in here. So dividing fractions, we're just going to follow those same steps, but we're going to add one at the beginning. So we're going to flip the second fraction. So we're going to keep, change, and flip, okay? And what that means is if we have 1/2 divided by 3/4, what we'll do now is we'll keep the first fraction the same. So we're going to go ahead and write down 1/2. We're going to change our operation from division to multiplication, and then we're going to flip the second fraction, right? We're going to write the reciprocal down. So flip that over. And then we follow those same 3 steps. We're going to multiply across the top. 1 times 4 is 4. We're going to multiply across the bottom with the denominators together. That gives you 6. And then we will simplify. So 4 and 6 have a common factor of 2. 2 goes into 4 twice, and 2 goes into 6 3 times. So 1/2 divided by 3/4 is going to be equal to 2/3. Let's do that again. So we're going to put some fractions here. Let's go with 5/6. We're going to divide by 2/7. And so again, we're going to follow that keep, change, flip. So we're going to keep the first fraction, change our operation, flip our second fraction, and then we're going to follow the rules for multiplying fractions. So we'll multiply across the top. So 5 times 7 is 35. Multiply across the bottom. 6 times 2 is 12. Now, you could leave this as an improper fraction in your algebra classes, and that's what's going to be expected. When you get to your 6th and 7th grade, they're going to want to write this as a mixed number. So what you're going to do is you're going to see, hey, does this 12 go into 35? Right now, we do have something we do. Let's go ahead and do that. So let's go 35 divided by 12, and let's see how many times that happens. So 12 goes into 35 twice. So 2 times 12 is 24. Subtract that, you get 1 and 1. So you get a remainder of 11. So that would be a mixed number of 2 and 11 twelfths. So in algebra, you're more than likely going to just write this as 35 over 12, because I'm used to seeing them, and you're going to be used to seeing them as improper fractions. In your 6th and 7th grade classes, more than likely, they're going to want you to write that as a mixed number, which would be 12 and, sorry, 2 and 11 twelfths, right? And that's the pretty simple form of multiplying and dividing fractions. Now, the last little thing I wanted to talk about, in algebra, you get a lot of expressions, a lot of equations that have multiple fractions in them, and it can be complicated to have all those fractions. So I thought I'd show you how to eliminate fractions from an equation. So let's do a little algebraic expression here. Let's go with 1/2 a plus 3/4 a plus 6/8 a. And we're going to say that all equals 3, just for fun. Okay? So here you're looking at going, oh man, I've got to come up with 3 fractions that are like fractions to be able to add this mess together. Well, if you don't want to work with all those fractions, you can eliminate them by multiplying by the least common multiple. 2, 4, and 8. What's the least common multiple? Well, your multiples are 2, 4, 6, 8, 10. Let's go 4, oops, 8, 12, 16. And then we've got 8, 16, and so on. But you can see right away, the first number that's the same for all of these is 8. So that is our least common multiple. If we multiply every single term by 8, it will be equivalent, because we've kept it balanced by multiplying everything by the same number, right? Multiplication property of equality. But it will also eliminate all these fractions. So let's see that in action. So 8 times 1/2 a plus 8 times 3/4 a plus 8 times 6/8 a equals 8 times 3. All right, so let's go ahead and multiply these. We get 8/2 a. All right, we get 24/4 a plus 48/8 a equals 24. Now, let's go ahead and simplify these. 8 divided by 2 is 4. We have 4a. 24 divided by 4 is 6. We have 6a. And 48 divided by 8 is 6. So we have 6a. And that equals 24. So now we have no fractions to work with, and this will be pretty easy to finish up. Okay. So again, the steps for doing that were: 1, we found the LCM, and then we multiplied every term by that LCM. And that will eliminate all of your fractions. Okay. So that's one way to do it. You could list them out like this to find, the multiples 2, 4, 6, 8. If you wanted to prime factor that, you might remember that as doing the branching when you factor it. But let's do another example with some more exciting fractions. So you can see just how frustrating it could be to come up with some more. So here we've got 5, 7, and 2 for our denominators. And luckily enough, this is easy enough to do. Right, you're going to multiply all of those together to get your LCM. So your LCM will be 70, right? 5 times 7 times 2 is 70. That's your LCM. So if I multiply each of those by the LCM, I will no longer have any fractions. And I'm hoping that some of you, maybe the majority of you, are going to simplify before you multiply with these fractions to kind of make it easier to deal with so you don't have such large numbers to work with. So if I wanted to simplify before I multiply, you can take the denominator, right, and see how many times it goes into this whole number. So you could say 5 goes into this once, and 5 goes into this 14 times, and then you would just multiply the 14 and the 2. So this would be 28a. 7 goes into this once, 7 goes into that 10 times. So 10 times 3 is 30. You have 30a there. And here, 2 goes into this once, 2 goes into that 35 times. Now you multiply 35 times 1 is just 35. Okay. And then over here, don't forget, this side also needs to be multiplied by that 70, so that is 210. And that's a pretty manageable equation to work with. Okay. Now I'm going to show you the prime factoring. So if we go back up to the 1/2 a plus 3/4 a plus 6/8 a equals 3. Well, I can look at all these numbers, the denominators there, I say 2, 4, and 8, and I can prime factor this. Well, that's just 2, first power. That's 2 times 2, or 2 squared. And this one is 2 times 4, 2 times 2, that is 2 cubed. So here it is, prime factored. So my LCM is going to be each one, 2, and then we're going to use the highest exponent that we have there. So it's 3. So we have 2 cubed, so that is 2 times 2 times 2, or 8. This would be your LCM if you wanted to do it with prime factoring. And I'm not going to go back through multiplying these, but again, it would be 8 times 1/2, 8 times 3/4, 8 times 6/8, and 8 times 3. Each one of these terms is going to need to be multiplied by that LCM to eliminate it. Okay, there are going to be some practice problems for you guys to work on.
Let's look at adding and subtracting decimals. Here we have 1.24 plus 0.86. Now the main thing when adding and subtracting decimals is you have to line up your decimal points. So the best way to do this is vertically. So if I have 1.24 plus 0.86, I line up just like that. My decimal points are lined up, so my numbers will flow along with it. So now we just add. 4 plus 6 is 10. 1. 1 plus 2 plus 8 is 11. Carry 1 over here. Now we just bring down our decimal point, and we get 1.1, and that equals 2. So our answer would be, I'll write it out, would just be 2.1. All right? Now let's look at 310.4 plus 12.05. All right, so we'll do the same thing. Set it vertically and line up our decimal points. So at the top we have 310.4. Bottom is 12.05. Let's add these up. So, in this case, we have an imaginary 0 behind our 4. Add them up. So 0 plus 5 is 5. 4 plus 0 is 4. Bring down a decimal point. 0 plus 2 is 2. 1 plus 1, 2. 3 plus pretty much nothing, or 0 if you want to put it there. So our answer should be 322.45. All right, now let's look at some subtraction problems. So, same exact way, we want to set them up vertically and set up with our decimal points. So we have 14.15 subtracted by 2.08. All right, so we have 5 minus 8. Of course, we can't do that, so we have to take 1 away from 1, turn that to 0, change this to 15. So 15 minus 8 is 7. 0 minus 0, of course, 0. 4 minus 2 is 2. Then 1 minus 0 will just give me 1. And that'll be my answer, 12.07. Now let's look at our last problem here. 2.8 minus 4.5. So in this case, usually when we set up vertically, definitely for subtraction, we have our bigger number up top. But now our bigger number is behind that subtraction sign. So let's use a rule that we know, keep, change, change, right? Keep our 2.8, change our subtraction to addition, and change that negative number, change the 4.5 to a negative 4.5. All right, so now you're going to be adding together 2.5 plus negative 4.5. There's a rule when you're adding unlike signs. All right, now the rule is you determine which number is bigger. So we have a positive 2.8 and negative 4.5. So as we know, the number 4.5 is bigger than 2.8. Don't worry about being negative positive, but we know since our negative number is bigger than our positive, our answer is going to be negative. And when we're adding unlike signs, you're really going to have to subtract the numbers. All right. So my bigger number up top, 4.5, subtract it by 2.8. All right. So if we do that, we have to take 1 away from the 4, so change that to 3. Change the 5 to 15. 15 minus 8 is 7. I'm done my decimal point. 3 minus 2 is 1. All right, so don't get worried and tricked around when you see adding unlike numbers. 1. So now let's multiply and divide decimals. Here we have 1.5 times 5. Now, we know from our basic rule that when you are multiplying two negatives, that my answer is automatically going to be a positive number, right? And when you're multiplying, let's set this up vertically. 1.5 times 5. All right? So 5 times 5 we know is 25. Carry the 2. 5 times 1 is 5, add a 2 to it, so we get 7. Now, what happens to that decimal point? Well, we look back at our problem and we count how many numbers are behind the decimal point. In this case, we have just 1, right? 1 number is behind the decimal point. So we're going to take that decimal, start all the way on the right side, and bring it in 1 time. All right. That's confusing. Let's look at another problem. Here we have 3.1 times negative 1.02. Set it up vertically as well. 3.1 times negative 1.02. All right. In this case, it doesn't really matter as much if the decimal points are lined up. All right. So let's just multiply. 2 times 1 is 2. 2 times 3, 6. Now we know we need to drop down a 0. 0 times 1 is 0. 0 times 3 is 0. Now we drop down 2 zeros for a 1. 1 times 1. 1 times 3 is 3. Now we get all this up. So we should get 6. Wow. No. We should get 2. We should get 2, 6, 1, 3. Right? So now we need to count to see how many numbers were behind our decimal points when we started out. So in this case, we had 1 number, 2, and 3. So we have 3 total numbers behind a decimal point. So that's how many times we're going to move our decimal. Starting from the right. 1, 2, 3. We have 3 times. And we have a positive times a negative number. So my answer is going to be a negative 3.162. All right. Now, when we divide, a little different. So here we have 0.12 divided by 0.2. How we set that up is our 0.2 divided by 0.12. All right. Now, when you're dividing, you can't divide by a decimal. So we have to make this 2 a whole number by moving that decimal point over 1. Now, whatever you do to the outside, you must do to the inside. So since we move this decimal to the right one, we have to do the same thing to this decimal. Move this to the right one. And once you move it, just plant it. All right? So really, if you want to look at a cleaner view, you have 2 dividing 1, 2. All right? Well, we could do this division. 2, can 2 go into 1? No. So we just put a 0 here, bring down a 1, decimal, and bring down our 2. How many times can 2 go into 12? Well, we know that is 6 times. And that's it. No, there's no remainder. So my answer for this will be 0.6. All right. Let's look at another problem. Here we have negative 14.52 divided by 0.006. All right. So divided by, I know that 0.006 is going to be on the outside of our box. And 14.52 by 2 is going to be on the inside. Right? So remember, we cannot divide by a decimal. So we have to change this decimal to a whole number by moving our decimal point to the right 3 times. And whatever you do to the outside, you must do the same thing to the inside. Move this decimal point over 3 times. And as we come to this blank area, we'll just drop a 0 here and a decimal point. All right. So in a cleaner view, I'm just going to change this to this. 2, 0. Drop our decimal point. I know that's where my decimal point is, right there. All right. So can 6 go into 1? No, of course it can't. But so changes to this, bring that a 1 and a 4. Can 6 go into 14? Yes. Goes into it twice. But 6 times 2 is 12. Subtraction, we'll get 25. 6 going to 25, of course. It goes into 25 4 times. 4. Bring that 1, 2. 6 can go into 2. 6 can go into 12 2 times. Then we have a 0 here. We'll just place a 0 here. All right. So my answer for this would be 2,420. And there'll be some problems for you that you're able to work on as well. All right, percents. So here we have a problem. Usually you will see these in more word formats. But the main thing about percents is you have to change this to decimal form. All right, so let's look at our problem here. It says, what is 37% of 100? Well, of tells us we're doing multiplication. Is tells us equal something. So if we wrote this out into a mathematical sentence, we'll have this equals, and we have to change that 30% to its decimal form. So to change that, you move your imaginary decimal to the right twice. So we get 0.37 times 100. All right. So to figure out our answer, all we have to do is 0.37 times 100. So I'm going to do that math over here. I'm going to do, let's do 100 times 0.7. All right. I know we get 0, 0, 7 times 1. Drop down to 0. 0. 3 times another 0, 0. 3 times 1, 3. Add it up. Not 32. 37. All right. Of course, those drop down to 2 zeros. So we know that there are 2 numbers behind our decimal point. So we go to our final answer. We start from the right, go 1, 2, and our answer should be 37. So we know that 37% of 100 is 37. That's my answer. Same thing down here. What is 25% of 24? So if we write this out in a mathematical form, what is 25%? So I want to change that percent to its decimal form. So 0.25 of 24. So we need to figure out 0.25 times 24. All right, so I'm going to write that over here. 0.25 times 4. All right. Remember, multiplication doesn't really matter how you line them up. You just multiply the numbers. So 4 times 5 is 20. 32. 4 times 2 is 8. Plus that 2 is 100. And put down a 0. 0. 1. 2 times 2 is 4. And 5. Add this up. You get 6, 0, 0. So now next thing we need to ask ourselves, how many numbers do we have behind a decimal? And we have 2 numbers behind the decimal. So we're going to move our decimal point, starting from the right, over twice. So my answer is going to be 6. All right. Now, there's another way we can see this, and that's saying 7 is 5% of what amount? Now, this is going to be worked a little different when we look at our math sentence. So we have 7 is, change that 5% to its decimal version, so 0.05, right? Move that decimal over twice. Of what number? So we don't know this time what number is multiplying it, all right? We don't know what number 5% is multiplying to get to 7. So to figure out this number, and you will learn this more next week with the one-step equation, is we have to divide each side by 0.5. All right, so to figure out this number, we're going to have to divide 7 by 0.5. So if I do 7 divided by 0.05, right? Change that. Gives me 0.05 on the outside of our box, 7 on the inside. And we should definitely know how to do this. Remember, we cannot divide by a decimal. So let's move that decimal in twice, right? And do the same thing to our 7. There's a decimal right behind the 7. We're going to move that twice and plant our point up in our zeros. So, can 5 go into 7? Yes, it goes into 7 one time. So we have 20, oh, sorry, 2. Then bring down a 0 to have 20. Now, can 5 go into 20? Yes, it can. It goes into 20 4 times. And then we just have zeros to finish out our answer. So we know that 140, which is our answer, 5% of 140 equals 7. All right. Look at us and do the same thing for our next problem. 30 is 15% of what number? All right. So 30 equals 0.15 of what number? We don't know. That's what we need to figure out. Something times 15 gives me 30. Or sorry, something times 0.15 gives me 30. So we know that to figure that out, we're going to need to divide. We need to do 30 divided by 0.15. All right, so 0.15 is outside of the box. 30 is inside. Can't divide by a decimal, so we have to move our decimal point in twice. So we do the same thing here. Move our decimal point to the right twice. And then plant our decimal point. So we know 15 can't go into 3. That's a 0 there. So I've done a 3, and then a 0. Can 15 go into 30? Of course it can. It goes into 30 twice. 30 minus 30 is 0. Then we can just replace this with a bunch of zeros behind it so we get to the decimal point. So we know that 200, which is the number that we were looking for, times 15% will give me 30. And that's how you have to work with percents.
We are the Perfect Squares signing off. See you next week. Bye.